Hi everyone, we're going to talk about chemical reactions. So evidence of a chemical reaction: a gas is produced without heating. You would see bubbles. A solid, a solid precipitate is formed when two solutions are combined. A permanent color change occurs, and you might see a heat or energy change. So in an exothermic reaction, um, heat is released, so your test tube, your reaction vessel would feel a little bit warm, and in an endothermic reaction, heat is absorbed, so your reaction vessel would be cold. When you're writing chemical equations, you're going to have the reactants on the left, so you have A plus B, and then your products on the right goes to C plus D. Okay, so you're going to start with your reactants, and then your new substance formed is your product on the right of the arrow. Things that you guys need to know are the different symbols, so that tell if you have a solid, a gas, a liquid. NR would mean that no reaction happens, and the delta sign means that there was heat involved in the reaction. AQ is a sign for an aqueous solution, and that means that ions or compounds are dissolved completely in the solution. So in an example here, we have an acid-base reaction. You have sulfuric acid, AQ, that means that that's aqueous. You'll find that acids are aqueous. And we have NaHCO3, this is a solid, and we form sodium sulfate, which is aqueous, water, which is liquid, and carbon dioxide, which is gas. So you would see bubbles in this reaction. We're going to, in this chapter, learn how to balance equations. So you'll notice that some of these have coefficients out in front of them, and that just implies that you have two of those compounds. If there's no coefficient out in front, that means that you have one of those compounds. Diatomic molecules are important to know. There are 7 diatomic molecules, and you can remember them by Have No Fear of Ice Cold Beer, and they are the H2N2, F2, O2, I2, Cl2, and Br2. So these guys here will never be just alone. They will always be with another element, or there will be two of themselves together. So like we would never see a hydrogen by itself. It would be, say, connected with oxygen or chlorine. You wouldn't just have H. And if you did just have a hydrogen, there would be two of them together. Okay, and that's how these guys will always exist. All right, so balancing chemical equations. The law of conservation of mass tells us that the number of atoms and the mass of each element must equal one another on both sides of the equation. So in this problem here, we notice that we have two H2s plus O2, and that goes to two H2Os. So this had to be balanced to get here by putting these coefficients out in the front. So we'll be doing that in this chapter. But what I want to point out is that what is on the left is equal to what is on the right. So notice we have 1, 2, 3, 4 hydrogens here on the left, and we have 1, 2, 3, 4 hydrogens on the right. We have 2 oxygens on the left, and we have 1, 2 oxygens on the right. So you will always need to have your equations balanced. All right, so here's how you would have put the equation together if we were forming H2O. We know that the diatomic molecules, hydrogen and oxygen, they have to be in twos. So I would start with H2 gas plus O2 gas goes to H2O. Now, when we're balancing the equations, we're going to adjust the coefficients. So what I do is I look here and I see, all right, I have 2 hydrogens on the right-hand side of the equation, and I have 2 hydrogens on the left-hand side of the equation. So that's actually balanced. But on the left here, I have 2 oxygens, and on the right I only have 1 oxygen. So those aren't balanced. We cannot go in here and just add a 2 right here and make it H2O2 because then that's no longer water. So what you need to do is you need to balance the coefficients. So you're going to put a 2 out in front here, which gives you the 2 oxygens, but that also now gives us 2 times 2, which is 4 hydrogens. So I need to make 4 hydrogens over here, so I would add a coefficient there. Okay, so now you'll see that everything does balance. I have my 2 times 2, which is 4 hydrogens. I have my 4 hydrogens. I have my 2 oxygens and my 2 oxygens. Okay, so balancing suggestions. Make sure that the formulas are correct to start out with, okay? And count the number of atoms for each element on both sides of the equation. When you do your balancing, you're going to change the coefficients, not the subscripts. And for polyatomic ions, you're going to balance them as a whole unit on both hands, if they stay a polyatomic ion on both sides of the equation. So there is a list of polyatomic ions in the chapter that we'll be working with, but a polyatomic ion would be something like carbonate, which is CO3 2 minus. Okay, this is the carbonate polyatomic ion. There are several that you guys will become familiar with. So if you have a polyatomic ion of carbonate on the left, you would want it to balance with the carbonate ion on the right-hand side of the equation as well. All right, you're going to save for last the elements that are present in 2 or more formulas. And you always want to make sure when you're done that you have the smallest set of whole numbers for the coefficients possible, okay? All right, so we're going to try this out here. So write and balance the reaction between potassium and bromine, which forms potassium bromide, which is a solid. All right, so if I am making KBr, it tells us that we have a reaction that's between potassium and bromine. Bromine is one of our diatomic molecules, so it always has to be in 2s. Bromine is a liquid, okay? And if we're forming KBr, if you guys remember from the nomenclature chapter, you have to make your charges balance. So potassium is K plus and Br is minus, so that becomes KBr. Okay, so that's going to be our product. That's how they came up with that. All right. Now, knowing that we have to have this bromine here as diatomic, I can see that we don't quite balance over here. Okay, I see that I have only 1 bromine on this side, but here I have 2 bromines. So what I can do is I can put a 2 out in front, which will give me the 2 bromines, but then that gives me 2 potassiums. So then I have to come over here and I have to put a 2 here to balance my potassiums. So what I do at the end is I always make sure that everything balances. So I just start from left to right. I have 2 potassiums and I have 2 potassiums. I have 2 bromines and I have 2, because this 2 is multiplied across, bromines. Okay, so everything here balances. All right, let's see here. So as a summary, first you need to write your reaction with the correct formulas. Like you did, you wrote the potassium and the bromine right up here. Potassium and the bromine. We know that bromine is Br2. And once you have done that, you cannot change the subscripts because then that changes what you have. So I cannot write K2, okay? You can only change the coefficients. So you're going to balance by adding coefficients. All right. So now what we're going to do is we're going to do a lot more balancing, but we're going to learn about the different types of chemical reactions that we have, okay? So we're going to learn to classify them. Is it a decomposition reaction, a combination reaction, an acid-base reaction? All right, so let's try that here. In a combination reaction, you are going to have, whoops, sorry about that. Here we go. I'll try to move up a little bit. Two or more reactants that combine to form one product. So here you'll notice I have reactant A and reactant Z, and they combine to form AZ. So you need to be able to classify this as a combination reaction and be able to balance given combination reactions. Now, if you notice a delta sign above the reaction arrow, that means that heat is required to make the reaction occur. All right, let's look at this one. We have sodium and chlorine gas. I know that this is going to be Cl2 because it is diatomic, and I'm forming NaCl. So I look at this equation and I have to see, does everything balance? I notice here I have one sodium, which is really good. Here I have one sodium, which is really good. Here I have two chlorines, but here I only have one chlorine. Okay, I cannot go and just add a subscript here because that would change NaCl, the table salt. That would make it not table salt anymore. So what I need to do is I need to change the coefficients. So if I put a 2 out in front here, whoops, here we go. Whoops, sorry about that. If I put a 2 out in front here, that gives us 2 chlorines, okay? And that also gives us 2 sodiums. And so in order to make that balance, I need to put a 2 out here in front of this sodium. So now I can go and check. I have 2 sodiums and 2 sodiums. I have 2 chlorines and 2 chlorines. Here's another combination reaction. I have solid lithium mixing with my bromine gas, and they combine to form LiBr. I know that this is the formula of the product because lithium, if you remember, has a +1 charge. I'm going to just put an itty bitty +1. You wouldn't ever do this on an actual reaction, but just to remind you of how these are formed from your nomenclature chapter. And bromine is a -1 charge, so these guys are going to go together. Simply LiBr, okay? Now I notice that they're not balanced because I have one bromine on this side and I have 2 bromines on this side. So I would need to make them balanced by adding a coefficient out in front here. That will give me 2 bromines, okay, 2 bromines. That also gives me 2 lithiums, and I only have one lithium here, and so I'm going to need to put a 2 out in front there. Now it looks like it's balanced, but I like to go through and check. So I have 2 lithiums and 2 lithiums. I have 2 bromines, okay, and I have 2, right, because this is multiplied across, 2 bromines. All right, so this guy here is balanced. All right, one last combination reaction. I have calcium solid combining with fluorine gas, and this makes calcium fluoride. How did I know how this went together? I just remember that calcium is a -2 charge, fluorine is a +2 charge, geez. And fluorine is a -1 charge, so I have to have 2 of them to make it balance. If you guys want to go back to your nomenclature notes, you can look at that. So this guy now balances with 2 fluorines, balancing with the calcium. So let's look at it and see if it balances. And it already does. I have 1 calcium, 2 fluorines, and 2 fluorines. So this time we didn't have to do anything. So combination reaction, 2 or more reactants combine to form one product. Good job.